Good morning, everybody. Today is Tuesday, October 18th, 2022. My name is Man with New Haircut, and today we're going to be working on the last concept doc and learning exercise for the Elixir syllabus on Exercism. So we've been working through all this fun stuff, and today we are at the last one, which is GenServer, which is a little bit more meaty. And we also have an example here called Take Number Deluxe, which we'll get started on. So yeah, we'll just jump right in. GenServer. So we've talked about processes as an abstract concept, not an abstract, but as a concept. And then we've talked about linking processes together, and we've used modules like task to accomplish things, and GenServer is the most is kind of like the base implementation of like, actually no, it's not the base, but it's the typical one that you kind of like start from when you're implementing your own little process manager. So anyway, GenServer, which is short for generic server, is a behavior that abstracts common client-server interactions between Elixir processes. Remember that the receive loop from when we learned about processes, the GenServer behavior provides abstractions for implementation, such as loops and GenServer behavior provides abstractions for implementing such loops and for exchanging messages with a process that runs such a loop. It makes it easier to keep state and execute asynchronous code. Be warned, the name GenServer is loaded. It is also used to describe a module that uses the GenServer behavior, as well as a process that was started from a module that uses GenServer behavior. The GenServer behavior defines one required callback, init, and a few interesting optional callbacks, handle call, handle cast, and handle info. The clients using a GenServer aren't supposed to call these callbacks directly. Instead, the GenServer module provides functions that clients can use to communicate with the GenServer process. Often, a single module defines both the client API, a set of functions that other parts of your Elixir app can call to communicate with the GenServer process, and server callback implementations which contain this GenServer logic. Let's take a look at a simple example of a GenServer first, and then learn what each callback means. This is an example server that can respond to the repetitive inquisitions of annoying passengers during a long road trip. More exactly, the question, "Are we there yet?" It keeps track of how many times this question has been asked, returning increasingly more annoyed responses. Interesting. So I've got a module called Annoying Passenger Autoresponder. It uses GenServer, and we learned before, use basically injects like default behavior, but allowing the module to kind of override things as they want. So this module implements defines start link, and internally it can calls GenServer.startLink, passing the module name and the initial arguments. Are we there yet is the kind of like public API, so that's what other Elixir code will call. And then internally, the way we answer that is basically we call GenServer.call, and we pass it the PID, which PID is basically the process identifier, passing the message, "Are we there yet?" And then you'll get back an answer. So to implement the GenServer, because we called use GenServer, we need to implement the GenServer stuff. So we're going to have an initial init function that takes the initial arguments, and then here is where you're going to create your initial state. And the way you're going to keep track of that is you're just going to return an OK tuple, and that initial state for us will just be a simple integer value. Then you handle the handle call. You implement a handle call function. Handle call listens for messages, and so the first argument is the message you want to handle. And so in this case, we're going to build handle call to pattern match for the very explicit message, "Are we there yet?" From is the where this request is coming from, and then state, which is the current state of the process. So inside a handle call, our job is to figure out what we want to answer. So they just do a little reply conditional, basically saying if state is less than or equal to 3, it'll return no. If state is less than or equal to 10, it'll say, I told you blank times already no. And otherwise, it'll return ... So if they ask for more than 10, it'll just do ... So we figure out what our reply is going to be based off of the previous state. Then what we're going to do is we're going to create a new version of state, which is basically just incrementing the current state plus 1. And then we will give a reply to this message. So this message comes in. This is our reply. We use the reply atom. Then what our response is, and then the new state. So that way the GenServer keeps track of what's going on. So init, a server can be started by calling GenServer.start or GenServer.startLink. We learned about the differences between those functions in the links concept. Those two functions accept a module implementing the GenServer behavior as the first argument, accept anything as the second argument called init_arg. As the name suggests, this argument gets passed to the init callback, accepts an optional third argument with advanced options for running processes that we will not cover. Starting a server by calling GenServer.start or GenServer.startLink will invoke the init callback in a blocking way. The return value of init dictates if the server can be started successfully. The init callback usually returns one of these values, either OK state, the server will start its receive loop, using state as the initial state. It's unfortunate they're using the same word for that there. Anyway, state can be of any type. Or the init could return stop reason, where reason can be of any type. The server will not start its receive loop. The process will exit with the given a reason. There are also more advanced possibilities that we won't cover. If the server's receive loop starts, the function GenServer.start3 or StartLink3 returns an OK PID, a tuple. Otherwise, they return error reasons. So yeah, so like when we call StartLink, the return type of this function is going to be an OK tuple with the PID, or will it always be? Or return OK PID, otherwise they return error reason, yeah. So handle call. So when a message comes in, as in the mailbox, a message that requires, I should just read, I shouldn't talk outside the concept doc. A message that requires a reply can be sent to a server process with GenServer.call. This function expects the PID of a running server process as the first argument, and the message as the second argument. The message can be of any type. Handle call, callback, is responsible for handling and responding to this synchronous message. It receives 3 arguments: the message, the value passed as the second argument to GenServer.call, from, which is the PID of the process that's calling GenServer.call. Most often this argument can be ignored. And then the state, the current state of the server. Remember that the initial value was set in the init callback. The handle call callback usually returns a 3 tuple of a reply atom, the reply you want to send, and then the new state of the process. This means that the second element in the tuple, a reply, can be of any type. It will be sent back to the caller. The third element in the tuple state is the new state of the server after handling the message. There are also more advanced possibilities that we will not cover now. To memorize what this callback does by its name, thinking of it as calling somebody on the phone, I like that. That's how I describe it as well. If that person is available, you receive a reply immediately, synchronously. Yeah, that's actually something that I use in my own stuff, because the alternative, which is handle cast, which we'll get to in a second, is the asynchronous version of this. So like when you do handle call, think of it like you are talking to somebody on the phone, and they are there, they are answering your questions immediately. Whereas cast is more asynchronous. So a message that doesn't require a reply can be sent to a server process with GenServer.cast. Its arguments are identical to those in GenServer.call. Handle cast callback is responsible for handling those messages. It receives 2 arguments, message and state. which are the same arguments in the handle call callback except for from. You don't know who the message is actually from. The handle cast callback usually returns a two-tuple of no reply state. There are also more advanced possibilities that we won't cover now. To memorize what this callback does by its name, remember that to cast is also mean to throw. If you throw a message in a bottle into the sea, you don't expect to receive a reply immediately or maybe ever. That's a good one. I always also think of cast as in fishing. Like when I cast my fishing rod, I may get a fish or I may not, and it'll take a while. So should I use call or cast? I almost always use call, even if your client code doesn't need the reply from the server. Using call waits for the reply, which serves as a back pressure mechanism to prevent clients from sending too many messages at once. Receiving a reply from the server is also the only way to be sure that the server received and handled the client's message. Handle info. Messages can also end up in the server's inbox by means of other than calling GenServer call or cast. For example, calling the plain send. To handle such messages, we use the handle info callback. This callback works exactly the same way as handle cast. GenServer behavior provides a catch-all implementation of handle info that logs errors about unexpected messages. If you override that default implementation, make sure you always include your own catch-all implementation. If you forget, the server will crash if it receives an unexpected message. And that handle info is typically used for more open-ended messages. So oftentimes messages will be put into the process mailbox via like a direct call from some other code. Sometimes you might get stuff there from like just arbitrary like notification things. Typically in like when you do web development with like Phoenix, you'll see pub sub notifications. Those are usually stuff that you'll find in the handle info area. So timeouts. The return value of each of the 4 callbacks described above can be extended by one more tuple element, a timeout. Instead of returning OK state from init, return OK state and timeout. The timeout can be used to detect a lack of messages in the mailbox for a specific period. If the server returns a timeout from one of its callbacks and the specified number of milliseconds have elapsed with no message arriving, handle info is called with timeout as the first argument. Cool. Yeah, I don't use timeout that much, but we'll see if the example has us do anything with it. So to exercise our knowledge of GenServer, we're going to be working in the Take a Number Deluxe exercise. Let's take a sip of coffee. All right. The basic Take a Number machine was selling really well, but some users were complaining about its lack of advanced features compared to other models available on the market. The manufacturer listened to user feedback and decided to release a deluxe model with more features, and you, once again, were tasked with writing the software for this machine. I don't even remember the Take a Number example. But the new features added to this deluxe model include keeping track of currently queued numbers, setting the minimum and maximum number. This will allow multiple deluxe Take a Number machines for queuing customers to different departments at the same time, at the same facility, and to tell apart the departments by the number range. Allowing certain numbers to skip the queue to provide priority service to pregnant women and the elderly. Auto shutdown to prevent accidentally leaving the machine on for the whole weekend and wasting energy. I'm pretty sure that's going to be the timeout stuff. The business logic of the machine was already implemented by your colleague and can be found in the module Take a Number Deluxe.state. Now your task is to wrap it in a GenServer. Okay. So with that explained, let's download the exercise and open it in VS Code. And we'll get started. All right, so now Q state. Okay. So there's a couple other things here. You don't need to read this module to solve the exercise. We would have used Erlang's Q module instead, but it lacks the delete function before TP24, and we want this exercise to work with older versions too. Okay, so let's not look at that. State is the state that this GenServer is actually going to use. And you can see it is a structure. So they have def struct, minimum number, maximum number, queue, auto shutdown timeout, infinity, and type. They got new, create a new state, create a new state, queue new number, serve next queue numbered, minimum maximum number is valid, timeout valid, find the next available number. Okay. Cool. And so then we're going to open up our README, and I'll hide the Explorer, and we'll get going. I'm hoping this doesn't take us too long, because I have a phone call coming up. But we'll see how it goes. If I need to cut the recording and come back, we'll do that. Start the machine. Use GenServer behavior in the tell number. Take a number Deluxe module. Use the GenServer behavior. Oh, they want us to use GenServer. That makes sense. Implement the start link function and the necessary GenServer callback. So, what did they give us here already? Server callbacks. Okay, so they want us to implement them down here. Okay. Okay, so implement the start link function and the necessary GenServer callback. So start link, like we saw in the concept doc. So you use GenServer, and so in start link you want to call GenServer.startLink with the initial options. So we'll just copy that straight in. We use __ module, all caps, to kind of replace this, so that'll all be replaced at compile time. And then start link will inevitably call an init method, which handles the default state. So this becomes the initial arguments, and then so in the concept doc they started state as state equals 0. We're gonna use the do we need to? Yeah, I'll alias this. Take a number Deluxe.state. So I'll alias that, and so that way down here we can just call state.new, and so state.new takes minimum, maximum, queue, timeout, infinity. So new, minimum number, maximum number, auto shutdown. So we need to give it a new. All right, let me finish reading the task, because we need to give that a default. Arguments passed to start link is a keyword list. It contains the keys min number and max number. The values under these two keys may be passed to the function state new. Okay. So, okay, so those are going to come inside here. We can, I'll capture them out here. So this is going to be called min number, and we'll say keyword.get init arg, and we're going to get the min number. If there is not one, do they say what to do? I should definitely finish reading this. The arguments passed to start link is a keyword list. It contains the keys min number and max number. The values under those keys need to be passed to the function take number state.new. If take number is taken to returns OK state tuple, the machine should start using the required state as its state. If the returns are error tuple instead, the machine should stop giving the return error as the reason for stopping. Okay. Oh, okay, so yeah, if you pass those. Okay, so we're going to assume that they're always there for now. And max number equals keyword Get init arg, and we will look for max number. And so we can't just return the state. We need to do this. So case state.new min number max number. So if this returns error reason, then we need to return let's see here, init stop reason. So the init callback usually returns one of these values, OK state, or stop reason, where reason is that. So okay, so we'll do stop reason, and if it returns OK formatter, we'll make this pretty. State. We'll return OK state, I believe. That format, I'll clean that up. I think that looks okay. You might notice the function state new also takes the optional third argument. We'll use that in the last step of this exercise. Okay. So I gotta open up the test file. Test take number deluxe test. So let's run all the tests in the Explorer so we can see these little green check marks in the sidebar. Task 1 is green, task 1 is green, task 2 is red. Cool. So, all right, let's move on to task 2. Report machine state. Implement the report state function in the necessary GenServer callback. The machine should reply to the caller with its current state. So they're going to start link, and we'll get access to the machine. And then they'll call report state, and they'll pass in the machine, which is basically the PID. And we'll need to respond to them. So once again, we'll look to our concept doc as kind of a reference. So like similar, like they implemented a public function there, and then they did genserver.call, and so we will do something similar. Did they say what we need to call the internal method? Probably not. It doesn't really matter. I'll just call report state. Machine. I'll just say machine. And then down here, we're going to need to implement the implementation for that call. And I'll just copy this just to get us started. So instead of answering that message, we're going to answer the message report state. Similarly, we will ignore the form. We will capture the state. Then what do we need to return? Just the state, right? New state. The reply is the state, right? Call. Yeah, just return the single term. Okay. Cool. So I think this is just, so the state's not going to change. The state's going to be the response. So that's just both there. Let's run the test and see. Task 2 is green, green. Task 3 is red. Okay, let's move on. Task 3, queue new numbers. Implement the queue new numbers function and the necessary GenServer callback. It should call take a number deluxe.state.queue new numbers function with the current state of the machine. If queue new numbers returns an OK, I'm going to finish drinking my coffee. If queue new numbers returns OK, new number, new state, tuple, the machine should reply to the caller with the new number and the new state as its state. Should reply to the caller with the new number and the new state as its state. That's a weird sentence. If it returns an error tuple instead, the machine should reply to the caller with the error and not change its state. Okay. So let's see here. Implement the queue number function. So I guess we'll just call ourselves. So like, we'll get state, and we'll call report state, and we'll pass it the machine, which is basically the PID. And then we're gonna call we'll call state dot Q new number, and we'll pass it in, and that's going to return different values. So let me move that over for a second so we can look at it. So Q new number is going to return either an OK integer in state or an error atom. So similarly, we'll look for error reason. Is it going to be reason? Error tuple instead. The machine should reply to the caller with the error and not change its state. Okay, so that's just going to be error reason, and if it's a successful one here is what? Okay, integer state. Okay, what does integer stand for? A lot of times it's helpful, like when you're doing a type spec, to like actually put a name here, so that way it's a little bit more explicit. Next available number. Next available number, new state. In that case, and it's going to get multi-line, so I'm going to make that multi-line as well. What do we need to return? If taken income returns OK state, the machine should reply to the caller. Reply to the caller with the new number and the new state. Okay, so you'd get OK1, OK2. Okay. Next available number. Oh, okay, so yeah, we definitely need to build this as a call because we need to change the state. And you can't change the state in an answer here. So, okay, so we're going to do a similar handle call. And we're going to call this Q new number. And we'll move this down here. Okay. Response. No. We don't want to do that. Okay, let me put this call in here. So this is going to call, it's going to make a GenServer call to the machine with the message Q new number. That will be handled synchronously. And so we don't need this anymore because we'll have the state inside of the call message. And then we either need to return this, where like this is our response and we're not going to change the state, or we need to return copy this, or we need to return this as the response and we need to store the new state. Okay, so let's go back to our test file and we'll run all tests in the Explorer. And task 3 is green, green. Task 4 is red. Okay. Serve next queued number. Implement serve next queued number function and the necessary GenServer callback. It should call state.serve next queued number function with the current state of the machine and its second optional argument priority number. if the serve next queued number, man, this is like these examples get really weird. Just like the business domain. If serve next queued number returns okay, next number new state tuple, the machine should reply to the caller with the next number and set the new state as its state. If the return is error, the machine should reply to the caller with the error and not change the state. So this is very similar. Is there anything going on here that's like different? Serve the next queued number. Okay. So similarly, we'll call and we're going to put a message called serve next queue number, and then we'll implement a handle call of that message, serve next number. Serve next queue number. So this takes, what does this take? This takes, takes the state and a priority number. Oh, are we gonna have to? Okay, this is I see where it's getting a little different. Okay, yeah. So serve next queued number takes a machine and the priority number, which defaults to nil. So the message is going to be a little different now. So the message, instead of just being a simple atom, we're going to make it a tuple. And so the message is going to be this complete tuple. And when we answer the call down here, we'll be able to pattern match the number that they actually want. So make that way we can actually, use it in our arguments list for serve next queued number. And this is actually this is pretty common. So instead of just posting a message that is just a plain atom, you'll see it often where it's actually a tuple that contains other value. Okay. So we're gonna do that. Similarly, his error is going to return to the caller the error and not change the state. So similarly, you'll get back a response that's like error reason. And similarly, if it returns, what is the return type of this function? Serve next queued number. Okay, integer. I think you'd call this queued number state, priority number not found, next number, priority number, next available number. I'm a little lost on what I should call this. I'm just gonna say next number. I don't know if that's like right. If I'm doing this wrong. Alright, let's go back to the tests. Let's run all the tests and see if these task 4 things pass. That's green, that's green, that's green, that's green, that's green. Task 5 is red. Alright, moving on. Task 5, reset state. Implement the reset state function and the necessary GenServer callback. It should call the new function to create new state using the current state's minimum and maximum numbers. The machine should set the new state as its state. It should not reply to the caller. So it just should return okay. Okay. So once again, we're going to, at the kind of like API level, we'll put our message in the box, and down here we'll implement a handle call. Yeah, it should still be handle call. I'm trying to think if they're gonna tell us to use a handle cast at some point, or handle info, but pretty sure this would just be handle call. And so the name here is going to be reset state, and we'll create a thing called new state equals state.new, and we'll just grab the previous minimum number and maximum. No, just max. Just called max number. And I guess, do we want to carry over the third argument, which we don't really use yet? Doesn't say that explicitly, so I'm not going to do that right now. And then the response, it's just nil, maybe? I don't know about that. Let me run all the tests. See if these pass. Yeah, returns okay, so this is failing. Why is this failing? Run a cursor. It expects. Oh, should I just return okay? Is that what I'm missing here? Okay. Run all tests in Explorer. Task 5, update state accordingly. This fails. Okay, why does this fail? We'll run a cursor. Updates the state accordingly. So, what line number is this? 182. Oh, that's the line of the 192 is where it's failing. So, after it calls reset state and that passes, the problem is this is returning okay and the state. And it's just expecting, why is it getting okay? Report state PID. I mean, the other report stuff still works, right? Yeah, those are all green. Take a number state. I mean, the value of the structure seems to match. It's just that it's expecting just the structure, and for some reason, the report state is returning back an OK tuple. I don't know why it would do that, because report state is just it just returns the state. It doesn't wrap it in an OK tuple. Run this again. Run a cursor. Why did you do that? Let me run all the tests in the console just so I can see. Yeah, we got a lot of failures because we're not there yet. We don't do the auto shutdown stuff yet. Fine. But the report state stuff, like all these pass. So it's curious why this would fail. Let's see here. Let me just go and look at this. So the report state test, report state, yeah, equals expected state. That makes sense. Reset state. Oh, you know why? Because I'm doing. So when I call like new state and like new returns an OK tuple. So I need to verify it. Should I just do that? Or should I handle the error? Do they tell me what to do in case of error? I mean, it should never fail because if it got through the init method and like, this error never happened, then restoring it should never happen. And so like I think it would be fair to just, look for OK here and then grab the state and then return it. I mean, if this crashes, you'll find out about it in your observability stuff. All right. So task 5 is green, green, green. That looks good. Now we need to do task 6. Implement auto shutdown. Oh boy, there's a lot. Take a sip of coffee. Modify starting the machine. It should read the value under the key auto shutdown timeout in the keyword list passed in the initial arguments and pass it as the third argument to take a number deluxe.state.new. Use the default value of infinity if auto shutdown timeout was not given. Modify resetting the machine state to also pass the thing. Okay, that makes sense. Modify the return values of all implemented callbacks to set a timeout. Use the value under the key auto shutdown timeout in the current machine state. Do not add the timeout to stop reason return value of init. Timeouts only apply after the server has started its receive loop. Implement GenServer callback to handle the timeout message that will be sent to the machine. If it doesn't receive any other messages within the given timeout, it should exit the process with the reason normal. Make sure to also handle any unexpected messages by ignoring them. So yeah, we're going to have to build a handle info for that. That's why it's doing it. After 3 hours. Man, I hope the test doesn't take 3 hours to run. Okay. So let's get started here. So we're going to look for auto shutdown timeout. And we're going to have a default. So infinity. And I guess do we want to put the default there, or so like if you look at new, it defaults. So like when you say new, min number, max number, if you don't have a third argument, it'll default to infinity. The challenge here, not the challenge, but like the thing to keep in mind here is that like if I do it like this, I'm kind of leaking the knowledge that infinity is the default from this. And I can't just I can't look for it, and if it's nil, it's nil, and like I pass in a nil value for here because nil will not pattern match it missing. So I'm gonna do this, but I don't really like this. I don't know. There's something about this I don't like, but I'll do it for now. Modify the resetting. So the resetting also should take advantage of that. So instead of state dot auto shut down timeout. So now if they reset the state, they will pull that value out of the previous state, which is all good. Modify the return values, implement all handle callbacks. Okay. So init doesn't need the timeout, but the other ones do. So if we come back to our concept documentation, we'll look at the timeout stuff. So the return value for each of the 4 callbacks can be extended by one more tuple element at timeout. Instead of returning OK state from init, return OK state timeout. The timeout can be used to detect a lack of messages in the mailbox for a specific period if the server returns a timeout from one of its callbacks in the handled. Okay. Return value. Default callbacks can be extended by one more tuple at timeout. E.g., instead of returning OK state from init, return OK state timeout. But they told us to modify the return values of all callbacks, init and all. Okay. To set a timeout, use the value returned under that. Do not add timeout to stop reason of init. Okay. So this would be timeout. Is infinity a valid time? I assume so. Yeah. Infinity is assumed. Okay. Okay. So then we also need to add it to all the other handles. So like when you do handle call, it's just a 4th argument in this tuple. Oh, that's why they have all these ors. So like it can be this, or it can be this. Okay. Okay, so we need to put that here. So that would just be states dot auto, what's it called? Auto shutdown timeout. So anywhere we return reply, we would add these timeouts. Right? Reply. Implement GenServer callback to handle the timeout message that will be sent to the machine if it doesn't receive any other messages. Okay. They didn't give us an They didn't give us an example, did they? With handle info. I mean, handle call, init, caller cast info. Yeah, they didn't really give us an example. To handle such messages, handle and call the caller works exactly the same way as cast does. So, as they mentioned, cast will do instead of returning reply, you return no reply. So, okay, let's do at impl GenServer define handle info, and this is where we're going to need to do our multiple ones. So we're going to need 2 because we're going to want one specifically for timeout is the message, right? Just timeout. And then the second is the state. Handle info is the message, and then that is just the state or some random term. Message is the state, values turned out the same as now. The callback is optional. Okay. And then this one will just be whatevs. Okay. So what do we need to do? Implement a GenServer callback to handle the timeout message that will be sent to the machine if it doesn't receive any other messages within the given timeout. It should exit the process with reason normal Exit the process with reason normal. Normal. Otherwise, make sure to handle any unexpected messages by ignoring them. Ignoring them? No reply state. I'm gonna capture this message and logger dot warning got. What we'll do, we'll say module got unexpected info message message. What are you unhappy? Oh, we gotta require a logger if we're gonna use it. Require logger. I think that would be a good thing to put there. And we don't need to do a reply, I guess. What are you complaining about? State is unused. Okay. My callback, make sure to handle. Let's try this out, see if this works or not. Run all tests in Explorer. So we've got task 6 is green, red. Auto shutdown works after handling unexpected message. Doesn't happen? Oh. It's because we gotta pass in our timeout state dot auto shutdown timeout. That makes sense. Run Explorer. It's still red. Why are you red? Run a cursor. Exception was raised. Protocol. Oh. What was the message? This is my logger. Yeah, 86. So it's trying to make a string out of message, but it's complaining because they're trying to pass in a tuple there. So to get that to work, you would just need to inspect the message, and inspect will return an appropriate string. All right, cool. That's all green. Let's run them down here. Mix test. We've got our warning. So yeah, Elixir take number Deluxe got unexpected message. Hello there. Why is that not green? They're all passed. That might just be a formatter thing because we got the logger there. Let me take the logger out and see if that's all green. Green. Yeah, that's good. Okay. I'm gonna leave the logger in. I think it's good. Cool. Is there anything we want to change about our implementation? I don't think so. I'm pretty happy with it for sake of Elixir Exercism stuff. So cool. So let us Exercism submit lib take number deluxe.ex, I think. And we'll open it up and see. Computers are happy. We'll take a peek at the community solutions. None of them are starred. I don't think many people star solutions. That seems like a weird little feature, but oh, so they do stop normal state instead of exit. Okay, what other people do? What do you do? Stop normal state. Okay, I feel like that's what we should be doing. Did they tell us about that in stop reason? That's in the init. Stop normal state. Okay. We need state. All right, let's do mix test one more time. Looks good. And we'll resubmit. Get our new iteration up. Is there any other community solutions that were doing anything terribly different or interesting? They grab the stuff out of there. I mean, they pass. Okay, so they pass. Yeah, they leak the knowledge there too. I suspect most people leak the knowledge because it's not particularly obvious how you would avoid doing that. Yeah, I mean, you would have to edit the module so it kind of publishes the default value. But so our iterations look good. They both pass, and we can go to our RWA. We'll mark it as complete. We will publish our iteration. We have completed all of the learning exercises through the Elixir syllabus. That is awesome. Cool. What a happy moment. So my intent. So hopefully, if you've watched, the entire series, I doubt anybody's watched the entire series, but if you've watched some of this and got some value out of it, I'm very happy. My intent at the moment is probably to pause this work for a little while as I focus on some other Elixir projects of mine. But I am going to keep the YouTube playlist up, and there is the chance that I may come back and start to do some of the other just exercises that are available. I think it would be cool to complete the entirety of the track, but that's a big ask to do on camera. There's still a lot of exercises, and we've only done. I've completed 40, and there's 116 available, which is a lot. So I don't know. I could see myself coming back to do some more, but definitely going to take some time off and work on some other projects. But I do hope to do more videos and talks and stuff. So yeah, thanks a lot for watching. Hope you had a good time. I will see you in next video. Not sure what that'll be, but yeah, have a great day, and we'll see you then. Bye bye.